Regression. A basic machine learning algorithm is often used for quality control in factories and to predict house prices. The word itself means to return or reduce to a previous or inferior state, which is fitting because regression reduces a whole dataset into a single equation. It's about finding an equation which can take in the input variables in a dataset and accurately calculate the output variable. Once we have this equation, we can toss this dataset, plug in new inputs to get the predicted output. When the output variables to be predicted are continuous values, we call it regression. If you're predicting discrete values, that's called classification. Linear regression is a specific type of regression where no terms exceed the power of 1. But how do we find the right equation that best represents the dataset? This best possible line... where's the title?
It's black!
Yes, chef!
Okay, it's good now. The best possible equation would minimize the difference between the output that it calculates and the actual outputs in the training dataset. This difference is squared to make sure all errors have a positive sign and larger errors are penalized more severely. How do you find this best fitting equation? One way is gradient descent. Imagine you are on top of a mountain and are trying to find the bottom of a valley while blindfolded. You can only feel the slope of the ground underneath your feet, so you take small steps in the direction that feels like it's going downhill. In regression, this means starting with a random guess for this equation and then making tiny adjustments to reduce the difference between the predicted outputs and the actual outputs until eventually you find the best fitting equation. That is the regression equation, and this is regression in 100 seconds.